Good afternoon, everyone, and welcome to the MSU Extension webinar series. My name is Mary Bowling, and I'm going to be the moderator for the webinar series. This is webinar number 3 of 4. We'll be ending on November 19th. And as indicated in the opening slides, Michigan State University programs are open to anyone and everyone. If you're having any technical difficulties, please let us know in the chat, and one of our behind the scenes staff will be happy to try and help. Today's webinar is being recorded and includes a presentation on water economics, finance, and planning, followed by Q&A with the presenters, and then a panel discussion and more Q&A with the panelists if time allows. Because this is a webinar format, the speaker option is not available for participants. Instead, please type your questions into the Q&A box, and my colleagues will be monitoring the questions and will present them during the Q&A portions of our agenda. Questions that go unanswered during the webinar will be addressed and sent out to all participants about a week after the webinar. Okay, let's go ahead and get started. Our presenters for the first portion of today's topic of water economics, finance, and planning are Dr. Steve Safferman and Brad Newman. Dr. Safferman is a professor in the Department of Biosystems and Agricultural Engineering at Michigan State University and has research, extension, and teaching appointments. Steve has a MS and PhD in environmental engineering and a Bachelor of Science in Civil Engineering, all from the University of Cincinnati. He also holds Ohio and Michigan professional engineering licenses. His research and extension programs focus on the fate and transport of nutrients applied to agricultural lands, system designs for waste to resource technologies, and wastewater treatment. Brad is an MSU senior extension educator who serves as an educational resource for local and tribal governments across Michigan's Upper Peninsula in the areas of land use planning and zoning, community and economic development, and general governance topics. He specializes in placemaking, planning, and zoning for renewable energy systems, local government climate adaptation and mitigation, green infrastructure and zoning issues related to the Michigan Right to Farm Act and the Land Division Act. Brad holds a Bachelor of Science degrees in Land Use Planning and Economics from Northern Michigan University and a MS degree in Natural Resource Economics and Policy from the University of Maine. Welcome, Steve and Brad. Thank you for joining us today. I'm going to stop sharing my screen so that you all can share yours.
All right, thank you, Mary, and welcome everyone to this session in the Water School. We're talking about water economics, planning, and finance, and I'd like to just give an acknowledgement to several others with MSU that are contributors to this program. So what we hope to accomplish here today is to help give Michigan communities, those of you tuning in today, a better appreciation for Michigan's water resources as it relates to the overall Michigan economy, as it pertains to local economies, and give some communities better strategies and approaches for incorporating water into their decision making, into their planning, into their financing, and the like. And so we're going to emphasize the importance of water to the local and regional economy. We'll talk about some ways to work water into the local planning process. We'll transition to then speaking about municipal finance a little bit and budgeting related to water infrastructure. And that will keep us going through the program and talking about some of those important water-related expenditures that so many Michigan communities find to be critical infrastructure. So 2 parts to the program to just summarize blue economy related concepts and the planning related to the economy and our local communities, and then those fiscal dimensions of water. So first, we're going to tee things up here talking about the blue economy. And no surprise that water resources represent a major asset and opportunity for the Michigan economy. Over the next several slides, we'll highlight different facets of the blue economy, including the importance to real estate, water-based industries, and sense of place and quality of life. And on this slide, what we see here is a concept plan from the city of Allegan with their strategy, one of their strategies to try to leverage a water asset, the river that they sit along, Kalamazoo River, and kind of reorient downtown towards that key asset. Over the next several slides, we'll talk about other ways to capitalize on water in local policies and plans. So first, no surprise that access to high quality water resources and the coastline of Michigan increases property values and adds to the tax base of Michigan communities. But so many Michigan communities still have what might be considered to be underutilized waterfronts. This is just a study on the screen from a Zillow real estate study of more than 100 million homes listed for sale, and the premium, the difference between those properties that are on water compared to those that are not. Now, this is not to suggest that every shoreline property should be developed and should be, say, taxable in the private market. We certainly wouldn't want that to be the case, because we know that public access to Michigan's waters are equally important as it relates to sense of place and the local economy. But it is to emphasize that, since we've come out of industrial times and the economy has evolved, Michigan communities really should be emphasizing how can we get those what might be older, contaminated industrial properties that maybe have sat idle for a while. How can we get those back to being productive? And we'd like to just emphasize and ask communities to prioritize that type of thinking in re-engaging those important waterfronts. We know that water quality affects property values too. Habitat improvements can contribute to property values and economic gain. We have a Brookings Institute report on the Great Lakes Regional Collaboration Restoration Strategy, or the GLRC, that shows property values increasing by 10% in coastal census tracts as a result of ongoing restoration projects. And certainly it's no surprise that water quality on inland lakes and also in the Great Lakes affects property values. Just one study here to highlight from Wisconsin lakes exposed to a common invasive plant. You've probably heard of Eurasian water milfoil. Inland lakes that are infested with Eurasian water milfoil saw a drop of about 13% in home values. So certainly some basic economics that relate to water access and water quality, and what that can do to not only the bottom line of individual property owners and those assets, but also direct ties to municipal finance as it relates to taxable value. Obviously, when we think about water as an asset, Michigan has a huge strategic advantage. Michigan tops the charts as the state with some of the most significant growth in water-based industries because of that significant asset. We see that within our major water-dependent industries, growth upwards of 8%, which is beyond, of course, national average, and much faster growth than we see across other sectors or the economy overall in the state. So tremendous opportunity there. And then, of course, some of that strategic advantage being that access, whether it's fresh water or even the groundwater that we have as a state. when we talk about the blue economy, it's often a conversation about water-based industries. And just to give folks a better idea of what some of those water-based industries are in the state of Michigan, we might classify some of those as living resources, right? This includes the fishing industry and aquaculture, seafood processing, and markets related to our Great Lakes and inland lakes. Marine construction, certainly a big thing, and some communities in Michigan have significant economies built around marine construction. Not only dredging and port construction, but also shipbuilding for sure. Ship and boat building has definitely not only recreational boats, Michigan has a history there, of course, but also ferries and fishing vessels as well. Of course, by far the fastest slice of the blue economy has been tourism and recreation related to our water-based resources. And that's not just boating and fishing, but also expanding that out to visits to aquariums, visits and spending time on scenic tours, lodging along the water, and restaurants for sure. Plus, there's the whole dimension of research and innovation, and that would include developing new water-related technologies and industries. So certainly Michigan has a lot of opportunity here, and in fact, at the state level, policymakers some years ago worked to pull together the Michigan Water Strategy. Perhaps some of you participating today even participated in focus groups when the water strategy was being developed. And this is a 30-year plan for Michigan decision makers, residents, to protect, manage, and enhance our water resources for generations to come. And so the goal is to really put a strategic focus on water technology, innovation, and to grow sustainable water-based economies here with the water strategy. I think even though this is a document prepared at the state level by the Office of the Great Lakes, it puts the point, or it emphasizes the point that really all communities should have their own water strategies. And we all have important assets that we can influence. A water strategy helps to put that in context and emphasize those points. So perhaps you are a community that has an ongoing and existing water-based industry. And how do you plan for that? How do we keep our working waterfronts accessible and create the space for those water-based industries? And then another part of that local strategy should definitely be about protection of those water resources, protecting access to those water resources in order to grow the local economy, in order for tourists and other recreational activities to make use of that. And naturally, when we talk about that access and the quality of life that proximity to fresh water or surface water provides, we've got to talk about placemaking strategies. And placemaking is a term that perhaps you've heard. It's really just the process of creating high quality places where people want to live, work, play, shop, learn, or visit. Screen here from Marquette and also Port Huron, but certainly across Michigan on the Great Lakes, there's lots of examples of communities that have done an excellent job of leveraging that unique sense of place on the Great Lakes in order to grow the local economy. And we'll hear some more about that with our panel, I think, later on. All of those aspects of developing a water strategy really come back to the local government incorporating water into the master plan. And so if we're going to enhance the local economy by leveraging water assets, we've got to incorporate water in the master plan. This is a official collection of policy statements that the community is interested in pursuing in order to pursue or to realize a vision for the community. We talk about planning for water at 3 different scales. We know, of course, that our political geography differs greatly from that of the ecology. And when we think about watersheds, we've got to be partnering at the watershed scale in order to make a difference here. Another scale that local government plans at is, of course, at that jurisdiction scale within that political geography. That's the authority with which the local government has to make future land use decisions and to adopt regulations. And so that gets us then to protection of water resources at the local or the site specific development project. And with that, of course, we're talking about different regulations, whether it be zoning, subdivision regulations, or other ways in order to protect resources at a given development site. And really, take this concept of partnering at the watershed scale statewide. We have over 1,850 local governments in the state of Michigan, and each of those has the authority to make its own planning and zoning related decisions. We can see, at this scale, it's not just the power to cooperate, but there really is a responsibility of local government to cooperate on planning for water. The planning process should prioritize, of course, those areas of the community that are most important for water, starting with an inventory of those water resources. We have to include wetlands, steep slopes, important areas for groundwater recharge. These lands may or may not currently be protected, and that's what the planning process will be able to identify, whether additional protection will be necessary. So from that inventory, combined with public engagement, we can actually, that's going to leave some additional areas for growth, for redevelopment, and that is exactly what the future land use map of a municipal master plan would suggest, is where those changes are most desired by the community. But a plan is only as good as the zoning that works with it. And so this planning process is just the start, and then the community follows up by adopting zoning, subdivision regulations, and other strategies for protecting those identified water resources. But the process we want to identify here is, you start with those critical water resources, plan for those, set those areas aside, and then let's talk about growth, development, and redevelopment outside of those valuable areas. Because in Michigan, it's not simply enough just to plan for surface water resources. We also need to be thinking about groundwater. Ground and surface water are really connected given our geology, and so there's this important two-pronged approach. And wellhead protection would be another example of a community being strategic depending on its water, drinking water, but thinking about where are those areas where groundwater recharge is so important. We have nearly half the state's population that gets its drinking water from groundwater. So this is also an important part of planning at that community scale. So as a community, we need to think about protecting surface water, groundwater, and planning for these resources at the watershed scale naturally then lends itself to a network or a systems thinking approach. And this is where we want to emphasize this concept of green infrastructure, because it is also reflective of this systems approach. And you can see a definition here from the Clean Water Act for what green infrastructure is. And it is something that can be used at a regional landscape scale in terms of planning, but also at that site-specific scale. And at this point, we want to take a break from the lecture and switch to a video that will be shown here. This video is about 6 minutes, and it's going to just highlight some ongoing initiatives related to green infrastructure in the mid-Michigan area.
Wetlands were once considered wastelands, but today we understand they perform many vital functions for society, such as
filtration is a big one. It takes water that's a lot of its nutrients, sediment, and allows that to settle out. The other thing is it's a holding area, detention area, so water can fill that and sit there and meter out slowly. That helps protect against flooding downstream. And the other thing is flashiness. When you have all these hard improved surfaces, when water runs off, it gets to an outlet very quickly. If we can get that into these natural low areas, it can act like a sponge and hold that water for a while and meter that out over time. So that helps the downstream from not rising up and out of the bank so quickly.
using the principles of wetlands. One system that's gaining in popularity are rain gardens.
A rain garden is one of many elements you find in low-impact design construction activities. It is the byproduct of allowing water to do its natural thing, soak through some medium and come out the other end clean. In this case, rain gardens are engineered gardens with vegetation in them, made of a special mixture of soil so that the water, polluted, can run through them and the soil acts as a filter to clean out the impurities in the water. Rain gardens also act to reduce the peak discharge, which is an important part of our job in managing water in urban areas. We want to prevent flooding. This neighborhood, for example, has over 150 individual rain gardens, a collection system of 8¼ miles of drain that run through the rain gardens before it goes to the Looking Glass River. This project has reduced the peak discharge to the Looking Glass River by 94%, which makes it almost pre-Columbus. You know, before the Europeans got here and rebuilt everything, created all this impervious, we've increased the flow of water off the land and thereby caused flooding problems all over the place. Downstream as far as Grand Rapids takes the brunt of what we do up here in a parking lot. So the rain gardens are one element you find within low impact design construction that filters the water, controls the flow of the water, and reduces peak discharge. The cost effectiveness, where it really shows the benefit of these things, that we caught the rainwater coming off of the streets, going into the rain gardens in this project, for example. We did the same thing at the toll gate drain, and we did it with another drain in Williamstown Township, where we constructed a wetland to handle the bulk of the flow. What it wound up doing is it showed about at the toll gate, it showed a 99.9% reduction in copper in the water. We had lead, mercury, chrome, all the different kinds of pollutants you will find from shingles on houses. Right, produces a runoff. When the rain hits it and the sun beats down on it, it produces a pollution. That pollution winds up being bound up in this dirt, goes nowhere, and it winds up being inert after sitting in the dirt for a while. It biodegrades, it goes away, and it's dealt with. The cost to replace these in terms of pollution removal, let's say 15 years from now I have to replace this dirt. I scrape up 2 feet of dirt and I take it to a landfill. I've got maybe a couple $100 landfill fee, and I replace the plants, a couple $3,000. It's cheaper than any other form of stormwater management, and the outcome in terms of quantity of flow, in terms of quality of flow, and duration of flow is extraordinary. I mean, it's just extraordinary. So when we talk about what it costs to operate these, you have to maintain it. We have to come in and treat them. If the flowers die, we have to plant new flowers. On this project, for example, which is an important aspect to this, is that you can take the $21 million and build a traditional system and not have to maintain it so heavy. Or you can spend $9 million on this and have to maintain it. The $11 million that I saved on this project will pay for 260 years worth of maintenance. So I don't know the argument about why we don't like to build them, because this is what I hear all the time, is we don't like to build them because we have to maintain them. Okay, so what? The toll gate drain cost $6.2 million. It saved $18 million from a traditional collect the water and take it to the river system, right? For $18 million, I can maintain that toll gate drain for 375 years and not spend what it would have cost to put the initial traditional system in. So I guess it begs the question, why not do this everywhere? Well, the engineering isn't common knowledge. They just starting to teach this in schools now. Municipalities are just starting to learn about it. The civil engineers that work for municipalities, they're just becoming aware of its benefits. Civil engineers have to sign off on the success or failure of things that they design. So when a community says, design me a stormwater system, they have to sign off on its success or failure and pay the liability costs if it fails, because they're the designer. Well, they're not sure they want to sign off for this because they're not sure of its success. We did an enormous amount of study and looked at all kinds of alternatives. And while rain gardens aren't the only low-impact design element you can use, there are dozens and dozens of ways to slow down the flow of water, control the pollution levels in it, and manage urban stormwater in a cost-effective way and have a cleaner environment.
The same principles of rain garden design can be applied by homeowners on a smaller scale too.
All right, thanks for showing that video, Caitlin. So we'll take that opportunity to transition into fiscal dimensions of water. And what we heard there from the Drain Commissioner is, the savings that could be realized with a different approach, a green infrastructure approach. And, it is said that an ounce of prevention is equal to a pound of cure. Basically, with local government and water resources, we're talking about planning, right? Planning, making a great deal of sense and being able to potentially deal with hundreds of smaller issues with a single planning, zoning, and other regulatory set of approaches. We can plan ahead to reduce the cost of building storm drain infrastructure, as we heard there. We can plan ahead to reduce water treatment costs, plan ahead to reduce energy expenses that we might have down the road, any number of things. And zoning in particular, as a way of implementing the master plan, can be an excellent tool to prevent a whole variety of issues from becoming something that is problematic. Here's a slide that's just highlighting some different capital and operating costs between what we might call conventional gray infrastructure, something like a new water filtration plant, and comparing it to what might be green infrastructure, right, as we heard about in that last video. So certainly the framework in New York is quite different than Michigan, and how drinking water is sourced is different. But the point being, there's lots of examples these days of approaches that have been a little more forward-looking, planning ahead in ways that helps to offset realizing future capital infrastructure needs. And in Michigan, we know that reducing expenses for improvements to infrastructure is incredibly important. We have a report from 2016 showing an annual gap in needed infrastructure improvements for drinking water related facilities being between $284 and $563 million per year. And you can see in another bullet there an even larger gap that relates to stormwater and wastewater infrastructure. So let's just switch gears here quickly to talk about how communities might plan for these kinds of capital investments. And what we have is a framework known as the Capital Improvement Program. So the prudent community will, plan for these kinds of expenses, and set aside funds for them, maybe initiate bonds within the community or some kind of lease payback method. And a framework for figuring all that out and thinking about the assets that we have that need to be replaced is that capital improvement program. And the idea of this from a municipal finance perspective is that we can budget money for predictable capital expenses, including repairs or replacement, and that by anticipating the lifespan of those facilities, we can plan and save for their eventual replacement. When we talk about capital improvements, we're talking about things that are one-time expenses. You know, these are generally large costs. I say one-time expense, that's within a reasonable period of time. These are things that have a many-year life expectancy. Capital expenditures are not operations. We're talking about facilities, some of those like you see on the screen. But it's not just these gray infrastructure types of facilities that we might plan and save for. We can also be thinking about land acquisition and building out that green infrastructure network as a capital expenditure for local government. All of this framework is built within the Michigan Planning Enabling Act. That's the enabling statute that gives government the authority to adopt a master plan for the future physical growth and development of the community. But it's also a statute that sets forth a framework for creating a plan for those capital infrastructure elements. And that's interesting. And it's the case that many of those land use decisions in the future have such a connection to infrastructure. And so we need to be thinking and planning about infrastructure in tandem with land use. So cities, villages, and counties are required to have a capital improvement program in Michigan, and it's an optional thing for townships unless they want to operate their own sewer and water. And we know that the CIP process is incredibly important for Michigan because the condition of Michigan's infrastructure is in dire straits. With that, I'm going to turn it over to my co-presenter, Dr. Safferman. Steve?
Okay, great. Thank you, Brad. So we're going to change to lots of concrete and big pipes now. And so we're going to start with the American Society of Civil Engineers 2018 Infrastructure Report. And so this kind of gets back to what Brad was saying about the cost of our infrastructure and just the amount of needs that's going to be in the future to maintain this infrastructure. So the ASCE 2018 Michigan Report card has all these rectangular icons, and each icon represents a part of our infrastructure, and it gives a letter grade in terms of what shape it's in. And you notice that overall Michigan has a D+, and then within those categories we have lots of C's and D's. I don't think we have anything above a C. And so many of these are related to water, just showing just the amount of infrastructure that relates to water and the great needs. So with keeping that in mind, we're going to start with looking at dam removal. So dams are all over the state of Michigan. And what are they there for? How come we have dams in Michigan? Well, mainly recreational purposes, hydropower for industries to supply water or energy, flood control, and water supply. So they were put in there with good intentions, obviously, but there's also quite a few issues with the dams. And so what's the problem with them? So there's safety issues, and there's two kinds of safety issues. The first is the safety issues with people that are doing recreational activities within the body of water. There's back currents after the dam, and they can trap people. And every year you hear about 1 to 2, sometimes 3 incidents within Michigan sometimes death associated with a dam. It doesn't have to be a big dam either. It can be a low head dam, but it also, you hear about it from the whole country. So there's even tracking of all these incidents with dams. But also, we don't have to look back very far and look to Midland, Michigan on the Edenville Dam and just the mass destruction that occurred on that dam. And so there's also a lot of other issues with dams that change the water temperature, which can change the habitat. The water quality can be impacted by the dams. The sediment transport is impacted, and we'll talk a little bit more about that. Habitat for fisheries and other wildlife, and also the connectivity. So in other words, one of the popular recreational activities is water trails, but if we have a dam in the middle of the river, then that actually prevents the water trail from progressing past that dam. And going back to the ASCE 2018 report card, we can observe that they estimate a $225 million increase in additional funds are needed in the next 20 years to manage the aging dam issue in the state. So how many dams are in Michigan? This map shows the number, each dot is a dam. So it's about 2,500 dams. Most will be were built between 1950 and 1980, even though there were some before and some after. And about 60% of them are privately owned, which is interesting. I wouldn't expect such a big number. Most of them are way below 20 feet, so 87% are below 19 feet, and 56% are below 9 feet. So most of these are smaller dams, and the color of the circle represents the risk from downstream. And so a low risk is green, and that means low risk to property and to safety, to health. Yellow is a significant risk to property. Red is a significant risk to both property and to safety. So what are considerations to remove a dam? First, for the age of the dam, how old is the dam? So typically these are built to last about 50 to 100 years. And if you look back at the dates when these dams were built between 1950 and 1980, you can see most of them are already past or at their useful life. And the other consideration in trying to decide what to do with the dams is repairing dams that are in poor condition can actually be a lot more expensive than just taking them out. In fact, the values show that it can be 3 to 5 times more expensive to repair a dam than just to remove the dam. And perhaps that's why we keep seeing the removal of dams increasing in the state. So we've had about 52 removed already in the past several years. And just looking at this photograph here, this is on MSU's campus. This is the Red Cedar River. And you can see these cracks here in the dam. And so those significant, but that's hard to know. Doing a structural evaluation of dam is very expensive, very difficult. So sometimes we don't even know if our dams are structurally stable or not. And then we have to look at stakeholder response. So stakeholder support, is there public in favor of removing this dam? Do they understand the consequences of removing the dam? Sometimes it can go either way. Some people like the environment and the atmosphere associated with the dam and do not want it removed. Environmental impacts, again, it can go both ways, but generally you improve environmental conditions by removing a dam, although temporarily you might actually have more problems when you first remove the dam. And then endangered species, often they have found endangered species living with the habitat caused by the dam, so that has to be managed. And then flood control can go either way. And so I have some schematics at the bottom photograph there. And those schematics show a model of that Red Cedar Dam. And it shows the first picture is for the current conditions. The second one is partial removal of the dam. And the third one is complete removal. In this case, removing the dam actually reduces the flood. So it gives it more capacity to store that water and actually would reduce the flood level by 2 feet. And that can be extremely significant. If you see the building in the background, 2 feet could mean the difference between that building flooding and not flooding. And then we also have recreation. So a dam backs up the water and makes a nice lake. That's a positive, but then it also prevents the connection of that river together, so you can't kayak through the dam. And sometimes these dams are historic structures, so that's a consideration, and also the wetlands that are produced by that dam, and then the channel reconfiguration that needs to occur if you do remove the dam. So lots and lots of considerations. So it just shows that to decide if you're going to remove a dam, you have to do a feasibility report to look at not just the cost, but also all the other factors that go into dams. So what's the removal process if you do decide it's time to remove it? So again, the political support's essential, and then you have to go through a preliminary design. And so there's many different ways to remove a dam. You can remove the whole dam or just partially remove it, to just remove it down slightly below the surface of the water. You can do a wet or dry removal. So do you put temporary dams in to dry remove it and try to minimize environmental consequences, or you just do it right in the river? Sediment control is probably one of the most important. So in this schematic, you can see the sediment behind the dam that has occurred for over 100 years. This can even be contaminated with hazardous materials. So if you just remove that dam, especially if you remove the entire dam, that sediment just flows down stream and can cause a substantial environmental problem. So often we do have to remove that sediment, and it's very expensive to remove it. If we do a partial remover, obviously we don't have to remove as much of the sediment. And then we have to look at the stability of infrastructure. So if we remove the dam, what about the piers? What about the bridges? Are we still structurally safe with the removal of this dam and the different water patterns? And there's also often a different grade from after the dam versus before the dam. And so we just can't have a grade difference, at least most likely we can't. So we have to fix that grade difference. And typically we use something called rock arches. And these rock arches are really highly engineered, and they're great for habitat restoration, and they also can be built to prevent erosion of the channel. So lots of different considerations. You have to consider funding. There are quite a few grants for removing dams. There's also some very innovative ways to remove a dam. I'm aware of the dam in the Great Miami River in Ohio. And this is, you can actually see from I-75 as you drive through Dayton, Ohio, right after the downtown area. And the Ohio Department of Transportation actually paid to remove that dam, because by doing that, they were assigned the mitigation credits, wetland mitigation credits, and they could use that for their transportation projects that took away wetlands. And so it was actually turned out to be a very good, inexpensive way for them to get those points, that credit, and that also benefited the community by getting rid of that dam that had no purpose at that point. Okay, we're going to switch gears now to water and wastewater. We're going to emphasize centralized wastewater treatment plants, even though there is on-site or a decentralized wastewater treatment plant. We won't have time to go into that. And so safe and clean water obviously is really essential for the well-being of society, but it's actually also very expensive, and we'll get into some of those costs here in a moment. But first, let's go over very briefly what wastewater entails, centralized wastewater. And you can see by this schematic that we first start with the pump station and go through these big screens that removes rags and so forth. Then we remove sand and grit material, so heavy inorganic materials. In this process right here, primary clarification removes organic solid materials like apple pits or whatever you can think of. And so then we go into this aeration basin. And so now you have the water looking pretty clear, but it's still impacted with dissolved materials that you don't really see. And the way we remove that is we have microorganisms eat up that dissolved materials, and they produce carbon dioxide, so the gas goes out passively, but they also produce biofloc that goes out. And we remove that biofloc in another set of sedimentation basins, and then we go through disinfection, and then we discharge it. So there's actually two streams going through here, the bulk liquid stream, but we also have the solid streams, these residuals. And even though these residuals are only 2% of the total flow that's going through this plant, they can cost up to 50% of the operational cost. But they also represent a resource. There's lots of energy embedded in that biosolids, or that sludge that comes out of the bottom of those tanks. And there's also lots of nutrients embedded in those. And just to show you the overview of the wastewater treatment plants, I have two views from Google Earth. The first one is the Delhi Township wastewater treatment plant. They have an average flow of 2.5 million gallons a day with a peak weather flow of 7.5. Notice the 0.25 mile marker on the top. And that's a relatively small plant, and it's kind of spread out. Even these lagoons over here are part of the plant, so lots of land. But notice the very compact plant here. This is Detroit, and Detroit's the largest wastewater treatment plant in the whole country. So right here in Detroit, it treats an average of 675 million gallons a day, and it can go up to 1.7 billion gallons. So imagine 1.7 billion gallons of milk. That's how much it's treating every single day. And so again, notice that mile marker here. And so even though this is a very compact plant, it's still very spread out in terms of the amount of acreage it takes. So with that quick background, we have a lot of energy to treat our wastewater. There's lots of equipment. In fact, 4 to 13% of the nation's electricity goes for moving and treating water. So that's an incredible amount of energy. In any given average municipality, 30 to 40% of their energy bill is on wastewater and water. So conserving energy can make a big impact in the community. And often a lot of simple changes can have a very quick payback period. So in other words, within a few months to a few years, you've paid that equipment back and you're now saving money. And so just to give you an example, there's a picture on the left here of a pump, and you can see the electrical service going into that, a very large blower with lots of electrical service, and this is a disinfection unit, again, taking a lot of electricity. And so we'll go back to the ASCE report card and look at the data for drinking water and for wastewater. So in terms of drinking water, it received a D, so very, very poor grade. And the numbers are astonishing. $13.05 billion required for drinking water infrastructure needs over the next 20 years. That's the estimate from American Society of Civil Engineers. And for wastewater, we're at about $2.1 billion over the next 20 years. So these are just astronomical amounts of funding to maintain and to improve our wastewater and drinking water system. Being a faculty member that teaches a lot of environmental engineering, companies can't even find students for this industry. There's just a gigantic demand for engineers that can design water and wastewater treatment plants at this time. So one reference that I strongly recommend is this energy roadmap put out by the Water Environment Federation. This document is designed for managers. It has lots of protocols and case studies about how to reduce energy at your wastewater treatment plant. And again, the amount of energy that's being used, you can make big impacts in terms of reducing your budget. And it also gives you benchmarks, which is interesting. So you can look at your wastewater treatment facility and compare it to others to see how you're doing in terms of energy usage. And certain the things that would be in this manual and some of the really low-hanging fruit include efficiency, improving efficiency. So a lot of the equipment that was put in wastewater treatment plant occurred over the 70s and early 80s because of big federal grants. A lot of this equipment is way past its lifetime, so it's being replaced anyway, but if we can replace it in a smart way, we can save a lot of energy. And this includes using variable frequency drives for our pumps, using LED lighting, right sizing pumps that are oversized are very inefficient, and using instrumentation and sensors to control equipment. And what's really great about these very low-hanging fruits is that a lot of the utilities have grant programs because during peak times, they want to minimize their energy use. And because it's very expensive for utilities to buy peak energy off the grid or to build plants, peak energy plants that only might be used 3 months out of the year. And there's also grants from the state to improve efficiency. The other option is to produce energy on site. And so this is a wastewater treatment plant or a landfill is a great place to put solar panels. And this is just one example and the results from putting solar panels above tanks. And this is in New Jersey. Or we can put wind turbines. And since this is a wastewater treatment plant anyway, you're probably not going to get a lot of complaints about wind turbines or solar panels. You might get complaints about the wastewater. And so again, a really good place to put some renewable energy to help offset the cost of operating this equipment and maybe even produce excess energy for this equipment. But we do have another option, and that's producing new energy from that waste that we talked about. So remember, 2% of that influent water actually comes out as a residual. We have to manage that residual, and that residual has a very high level of energy potential. In fact, 350 to 525 kilowatt hours per million gallons energy potential. And we can even increase that by blending it with food waste from the community and divert that food waste from the landfill. And there's actually some really interesting cases. Delhi Township, this is a picture of the digesters in Delhi Township. They actually have a program in the schools for the kids to sort their waste at the cafeterias, and then that gets shipped to the wastewater treatment plant and it produces energy. So a really cool program. They have a mascot, they have a video, and the wastewater people go to the schools and try to teach the kids about why they're separating their waste. And so just like we use natural gas and it's produced in geological time. That's what we do as engineers. We produce natural gas from the waste using these reactors. And instead of doing it over tens of thousands of years, we do this over about 15-day period. And so we have a lot more capacity to produce a lot more energy at wastewater treatment plants. Right now, a very small fraction of our treatment plants have these energy generating systems in there. Most of them use energy to treat the residuals instead of gaining energy from their residuals. So this is a great opportunity. The trouble is it's very expensive to build these complexes. And these do have a longer payback period in the 9 to 12 years compared to just a year when you right size a pump or put a sensor in and put a monitor on your disinfection system. So with that, I want to close off and thank everybody for attending today. And I think at this time, we're going to try to answer some questions that you might all have.
Yep. Thank you, Brad and Steve. That was a great presentation. Really put things in perspective for us. Next, we're going to go to questions. And so we have about a little over 10 minutes left for questions. So I'm going to turn it over to my colleague at Sea Grant, Geneva Langland, who will pose questions to Steve and Brad. And just a reminder, if you have a question, enter that in the Q&A section of the toolbar or the chat. So go ahead, Geneva, take it over.
Thanks, Mary, and thanks to our presenters for kicking it off for us today. We've got a few questions in the box, and like Mary said, I'd invite you to keep sending those through into the Q&A box accessible through your Zoom toolbar, which is likely at the bottom of your screen. So let's start out with a question about the sediment that accumulates near a dam. There are concerns that that sediment might contain harmful chemicals. What are some of the kind of balancing factors that come into play when thinking about sediment and dam removals, and what might be done about that?
Yeah, you have very much a large problem. So the first thing that you need to do is sample the sediment, and not just for even the contamination, but how much of it is, because that's a major cost of removal. And then unfortunately, a lot of it does have some impacted material in it, like cadmium or chromium or lead. And so depending on the results of the sample determines on how you get rid of it. So if it's low enough, you can dredge it and then bring it to a regular landfill or some other sort of fill site. If it is hazardous, if it does have a lot of heavy metals or other materials or organic materials like PCBs, then you have to bring it to a hazardous waste site. And this can just double or triple the amount of money that it's going to cost to manage that sediment. So every site's completely different. So you have to do that feasibility study or that sample analysis up front to know what you're dealing with. And that might even be a go or no go, because really if the sediment's deeply buried, it's probably not going to serve, not going to be a risk. In fact, taking it out could distribute it temporarily. But if you have to take it out, it could be very, very expensive. And keep in mind, some of these dams have been around for 100 years, 50 years. Environmental regulations were a lot different 50 years ago, 100 years ago. The dam that I showed a picture of at MSU was built in the 1890s. And so who knows what's in that sediment? There could be some surprises. And in fact, we had just had a conversation about this, and that is the next step in terms of MSU considering what to do with that dam, is to look and sample that sediment.
Great, thank you. Let's see. So we've seen plenty of evidence that we are already experiencing stronger storms in the Great Lakes region, storms that happen more intensely and that often bring more precipitation when they do arrive. What are some considerations for managing for stronger storm events, especially as we count on seeing more of those in the future?
I'll leave that one out. So yeah, certainly extreme precipitation is a major concern for Michigan communities. And we know that when the water falls, it has to go somewhere. And I think one principal thing that communities need to think about is all that impervious surface and all of that stormwater that flashes off surfaces in a quick fashion during an extreme storm event can be handled in a couple of different ways. Certainly we can try to move it into retention basins and store it on site. We can get it into pipes, and hopefully we've got the capacity in a stormwater system to be able to handle it. That may or may not be a combined system. If it's combined, that's going to be an awful lot of water going to the water treatment plant. That's going to, stress that system. Steve can talk about that for sure. Another set of strategies would be those that really relate to that green infrastructure concept. I think communities can plan at that community and watershed scale, thinking about where those riparian ways are, where are the intermittent stream flow areas, where are the wetlands that might store some of this extra water, and think about trying to build out that green infrastructure network so that we have more natural landscape that can slow that flow down, that can absorb that water, that can naturally process some of the pollutants in that stormwater. Then another piece of that is creating larger natural buffers, say from the shoreline. Certainly larger storm events that might be pounding our communities, and with high water, we can see significant damage there. So how can we try to make that shoreline more resilient? Perhaps by larger setbacks on new construction, or restoration initiatives, or relocating infrastructure away from a hazardous or threatened state closer to the shoreline. All those investments in additional property or rebuilding of infrastructure, of course, takes planning, takes budgeting, and it's not a small task. So I think it's something that all Michigan communities definitely need to be paying more attention to.
Yeah, I think that was spot on, and just I'm actually kind of encouraged because there's a lot of attention now to green infrastructure and stormwater management, and a lot of good engineered solutions to it. But another consideration is, if we can put our stormwater back into the ground, we also have declining aquifer levels in many locations, and that's also another advantage of trying not to ship it and move it away from where it's been landing, and get it back into that groundwater and have it infiltrate. And that's what a lot of these technologies do.
Kind of on a similar vein, we talked earlier about the importance of protecting areas that provide groundwater recharge, and like you said, being able to keep those aquacultures filled. How are recharge areas identified, and what are some of the ways to protect them?
Well, the wellhead protection program involves quite an extensive amount of field work. So a community that is interested in adopting a wellhead protection program would get assistance from the state, from Energy, Great Lakes, and the environment to really model and understand groundwater recharge specific to a particular well location. So that is part of the question. Outside of the wellhead protection program, I know the Institute for Water Research at MSU does quite a bit of groundwater modeling. Some of that might exist for your county based on previous work, but it might be a contractual service that you need to hire, either from an institution like MSU or from consulting engineers that could do sampling and modeling of that specific to your geography, geology.
Yeah, just one of the personal experience, what kind of personal experience, I used to live in Dayton, Ohio, and the wellhead protection program actually initiated in Dayton, Ohio, due to an intense fire at a paint manufacturer, and it almost contaminated Dayton's water supply, and that actually led to wellhead protection because of that very close to catastrophic event. So I don't I don't think we can emphasize enough how important it is to protect the groundwater, especially in general, but especially where our water supply is. So I think this is just a really important component that we all should take really seriously.
Thanks. We got a few more minutes for questions. We've got probably more in the box than we'll be able to get to now, but as a reminder, we will be sending out a follow-up email to participants with answers to the questions that we weren't able to get to live. A question about dams in communities. So as we know from the dam events earlier this year, it's pretty important to have information available about the safety or current status of dams in a given community. Is there a place where people might go to find out information that's been collected on the dams in their area?
There is. In fact, there's some really good websites out there, and you will receive a follow-up email with the addresses for those websites. But Eagle was DEQ, but now it's Eagle, does have a website and lots of good information. And so you can look up your dam specifically, and then also there's some contacts that you could call, and you can ask about your specific dam. There are inspectors that go around, so most likely the dam that you're referring to has been categorized, cataloged, and there should be some information about that either online or if you call up someone from Eagle.
Thanks. We have a question about green infrastructure in urban neighborhoods, specifically wondering about detention basins in urban neighborhoods and what kind of considerations come around maintaining those kinds of basins.
Well, one of the big maintenance issues is getting sediment out of those, and as the water's running off of surfaces, it's carrying particles with it, sediment, and those will fill in. I know City of Marquette, I can't tell you what the budget expense of that is. Maybe our panelists can speak to it, but some of the quasi green infrastructure that they have does require annually, getting in there and removing sediment. And it can be a significant expense, but depending on the savings from the investment, as we heard in the video, it can certainly be offset. Depending on what the plants are in a, say, rain garden or a larger, more man-made swale, there certainly is maintenance related to, replanting or enhancing those materials. So those are some real expenses or maintenance expenditures, and maybe public works staff at the municipality doesn't have some of the equipment or some of that experience, and so I think some of the maintenance on these things, it'll be important to have partnerships. There's probably groups within the community that might take an interest in maintaining vegetation in some of these types of resources. A network of master gardener volunteers would be one excellent group to partner with in order to plant and even maintain a rain garden system.
Yeah, and I think it's really important to know there's actually two types of basins. One is that retention basin that's just kind of storing the water and then letting it go out at slower rates and trying to reduce the flashiness of the peak flows. But there's also an infiltration basin that's designed to have the water go down through the bottom of the basin into the groundwater. And so they always have an emergency discharge. But as Brad mentioned, they have to be maintained. If the sediment builds up, that's going to sail off the bottom of that basin. It's only going to be serving as a retention basin, not its original design. And so, and also a lot of times these have plants in them. And so if the plants, you get weedy plants in there and they start to get really thick root mats, that's again going to sail off potentially the bottom of this. So maintenance is absolutely critical, and understanding what that basin was designed to do originally is really important.
Great, thank you for that. So it is about time to move on to the next segment of the webinar, but I did want to follow up on one comment that somebody made talking about the shortage of engineers who study waste treatment And I can just sort of personally attest my dad just retired from that field and does indeed see a gap in younger engineers who are coming up into the waste treatment field. So if anybody has people that they would like to encourage into that field, I know that there is a great need for it. Every community needs to deal with waste somehow. So the more engineers we have trained to handle it, the better. And with that, I think I will pass it on to Mary to bring us to our next segment.
Thanks, Geneva, and thanks for all the great questions that everybody posed, and thanks to Steve and Brad for the presentation as well as answering the questions. Now I'd like to move forward with our panelist portion of the webinar. We have a great group of panelists with a diversity of backgrounds from different parts of the state of Michigan. So first up, we have David Stensis, who has served as the city planner and zoning administrator for the city of Marquette since late 2010. And Dave has also worked as a transportation planner for a bi-state metropolitan planning organization, as an ecologist and hydrologic technician for the U.S. Forest Service, and also as a skilled tradesman, so lots of variety in his background. He's a staff liaison to the City of Marquette's Planning Commission and has led them through a major in-house overhaul of the city's community master plan. Dave secured grant funding for and coordinated the creation and adoption of a land development code in early 2019 that replaced several outdated ordinances, including zoning. Environmental concerns, particularly stormwater management and the protection of riparian areas, were emphasized in the land development code in several ways. And Dave has also been instrumental in the creation and adoption of a complete streets policy for the city of Marquette back in 2011, and the planning and implementation of an on-street bike route network in Marquette that he worked on for several years. And Dave holds a master's degree in urban and regional planning from Eastern Washington University. Next is Brian Ross, and Brian is a senior assistant director for the Genesee County Drain Commissioner. He's responsible for the operation, maintenance, and funding for 3 wastewater treatment facilities, serving a total of 44 different communities, and then 1 drinking water facility that serves 17 communities. Brian has been employed and actively involved in the utility service sector for over 42 years. He served in leadership roles in both state and local government for many years, and he has a Class A wastewater certification and holds numerous drinking water licenses in both treatment and distribution. Brian is a 1980 graduate of Michigan State University. And our third panelist is Marcy Hamilton. She's the Deputy Executive Director and Senior Planner for the Southwest Michigan Planning Commission. For over 20 years, Marcy has been working with Southwest Michigan communities to protect and improve water resources. She has also participated in many statewide efforts, such as serving on Michigan's Water Cabinet to develop the state's first water strategy. She has a wealth of experience writing master and recreation plans, facilitating planning processes, and developing grants and implementing projects in watershed planning, economic development, and recreation. She holds a bachelor's degree in biology and environmental studies from Ohio Northern University and a Master of Environmental Science degree from Miami University in Ohio. So before I get to the questions that I prepared for the panelists, I'd like to invite each of the panelists to take just a couple of minutes to give a little more information about their background on the subject of water economics, finance, and planning. So Mr. Stensis, would you like to go first? Remember, you'll need to unmute.
Hi, yeah, this is Dave. I'm standing in today for our Director of Community Development, Dennis Stakowitz, who is unavailable this week, but I'm very glad to be able to be here and help with this panel discussion. Marquette is, as most people around the state probably know, a coastal community. We're a deep water port on Lake Superior, and the city was established for that reason, to be a deep water port a facility for shipping iron ore primarily. And as a city built on the waterfront, we've had a lot of transition since that early industrial era. And we're at a point where the industrial era is over, the heavy industrial era is over, and we're transitioning to a different, much more diversified economy. And as a result of that, the community has much different expectations for use of the waterfront. We have, fortunately, a great deal of our waterfront is public property and provides public access. And so we have a lot of competing interests in that waterfront, but overwhelmingly we have a lot of public support to protect our waterfront here in Marquette. And so as a planner here in the community, we deal with all those competing interests, and so I think Marquette was a nice small town to add to this panel.
Yeah, that's for sure. It's a great example. Thank you, David. Mr. Ross, would you like to go next?
Sure, I'd be glad to go. Thank you, Mary. And I wanted to take a minute to say thank you to Steve and Safferman and Mary Bowling. And I really wanted to thank the other presenters, Brad, Marcy, Dave, and Caitlin, for their opportunity to be part of this water school program. I'm really honored to be mixed in with such a great group. Well, like Mary said, I've been in the water and wastewater business for about 42 years now, believe it or not. I started out as a janitor and a night monitor at the East Lansing Meridian Water and Sewer Authority in 1978 while I attended MSU. And I worked there both as a janitor and then later at the wastewater plant as an operator and technician. I worked 8 years in private industry as a facilities manager, which included all the utilities, 10 years as a director of a regional wastewater facility. And we also ran 3 water systems north of Lansing. Then I was lucky enough to land a job for about another 7 years as superintendent of Lansing's wastewater plant, which is about the 5th largest plant in the state. And for the past 11 years, I've served in several capacities for the Drain Commissioner's Office. I always see the water and wastewater business as the silent industry. We're out of sight, we're out of mind, we have stuff buried in the ground. People kind of forget about us until there's a problem. And then our industry gets in front page news, and it's not when we want it and it's not reported how we want it, but we're there. And I think with recent water catastrophes, the Flint water crisis, the collapse of the large interceptor sewer pipe in Fraser, Michigan, 2 dams that broke recently and flooded Midland, as well as recent high water levels in the Great Lakes. And these water levels are so high, you have houses that were built in the late 1800s that have eroded to the point where they've fallen into the lake. And these events, albeit not pleasant ones, they brought about a new look at our industry with the aging infrastructure, as Steve talked about. A D plus was maybe the best overall rating we got. And like Steve mentioned, a shortage of talent in this industry and the difficulty in hiring people. Our industry certainly faces a lot of challenges coming up, and you can either shy away from that or you can look at that as quite an exciting opportunity in Michigan.
Great, thanks, Brian. I'm glad to have your expertise on our panel. So Ms. Hamilton, would you like to go next?
Sure, thanks. Yeah, so I'm over in the southwest corner of the state. We are a regional planning agency that covers Berrien, Cass, and Van Buren counties. And for those who don't know what regional planning organizations are, there's 14 regions in Michigan that have these regional planning agencies, and we work created by the state government to basically assist the communities with all types of issues that are regional nature, such as transportation, economic development, of course, environmental protection, our water flows, doesn't consider political boundaries. It flows across the landscape. So any kind of water issue is regional usually. So I've worked with communities in our 3 counties for over 20 years, like Mary said, on their master plans, trying to work with them to get information about their water resources in those plans, and then work with them on their zoning ordinances to implement those plans to protect the water. Our area is very agricultural. Over 50% of the land in our 3 counties is in agriculture, and we're lucky to have a lot of specialty crops. Berrien County is actually second in crop diversity, only to Orange County, California. So very diverse agriculture that depends on clean, good water for that industry. So we also are very dependent on tourism in our area. So we're being all of our beach towns, obviously we're very dependent on Lake Michigan and the water resources that we have. So I'm glad to be on the panel and look forward to answering those questions.
Great, glad you're here. So now let's get started with the panel discussion. I'll be asking a series of questions and then give the panelists an opportunity to answer. So not all questions will be answered by all panelists, but let's go ahead, and if your bandwidth allows you to and you want to share your videos, go ahead and turn your videos on, panelists. And I'll have your first question for you. How should Michigan be positioning itself to strategically leverage our freshwater resources? So Brian, did you want to go first with that one?
Sure, I'd be glad to. It's a great question, but before I answer the question, I wanted to throw out a little fun fact. Let me say Michigan's home to 95% of the entire freshwater supply of the United States. And that means that we have access to 6 quadrillion gallons of fresh water. That's a 6 with 15 zeros behind it. It's hard to get my mind around that, I know that. And here's another just a little fun fact. If you were to take all the water stored in the Great Lakes, spread it out over the continental United States, the country would be under about 9.5 feet of water. So how should Michigan begin positioning itself to leverage these resources? I think the simple answer is we should consider using it strategically to bring both people and environmentally responsible businesses back to our great state. It's not a surprise that 3 out of the top 5 industries in Michigan are manufacturing, tourism, and agriculture. And if you include fishing and food processing in that agriculture group. These 3 industries rely heavily on an abundant supply of clean water. But these industries do more than that. They employ about 1.2 million people. 1.2 million in the area, and it's responsible for about $80 billion in wages, most of which stays locally in Michigan. There's over 800,000 manufacturing jobs that rely on Great Lakes to make, store, transport their products. Another 240,000 jobs as a direct result of the tourism industry. And the local Great Lakes communities benefited from serving over 115 million tourists to Michigan. Some of them were within Michigan, but a lot of them out of state that come here and then spend their money here. In fact, so much so they spent $22 billion. Agriculture, if you include commercial fishing, food processing, employs another 133,000. So you can see that Michigan's surface and groundwater resources certainly are vitally important to many people and many businesses. Manufacturing, tourism, agriculture, those are just 3 of the ones that I mentioned. But there's also public drinking water supplies like our facility provides, electrical utilities, mining industry, And those are all dependent on abundant and clean sources of water. Now, Brad mentioned earlier the water strategy document. If you haven't read it, go online. It's not the kind of thing that'll put you to sleep. It's presented in a way that's very interesting. And the strategies of that 30-year plan for Michiganders to protect, manage, and enhance their water resources for current and future generations. But there's also the strategy identifies key actions to promote healthy water resources. So take the opportunity to read it. Go to michigan.gov, look up the Department of Environment, Great Lakes, and Energy, and search with the keywords Michigan's water strategy. I believe we should position ourselves to market our water resources in a responsible manner, to invite businesses that rely on clean water to consider relocating here, or if they're already here, expand their existing business. It's an opportunity to advance Michigan's future prosperity.
Great, thanks, Brian. I appreciate that. David, what's your take on this with Marquette?
First of all, I've tried to start my video, but it tells me the host has stopped it. So I'm not sure what's going on with my camera, but I'll proceed to the question. As far as strategically leveraging our freshwater resources, strategically planning, it's a planning issue, but there are a few key concepts that jump out to me in trying to answer this question. First is protection of water quality. The second is thinking of fresh water itself as infrastructure. And three, being more strategic with the extension of our gray infrastructure. So on protecting our water quality should be our top priority, in my opinion. We have an abundance of water. The quantity of the water that's available to us is a blessing that really allows us in most places to simply focus on protecting our water quality in Michigan. But that involves a lot of issues throughout the state, preventing pollution from reaching the Great Lakes, preventing the growth of toxic algae blooms in the lakes, keeping oil out of the lakes, protecting the lakes from invasive species, conserving the sensitive marine ecosystems and unique sites along the lakes. And that includes inland lakes, not just Great Lakes. But at the local level, stormwater management related to land use and development is something we have some authority over. So effective stormwater management to reduce the amount of pollution reaching groundwater is extremely important. Groundwater forms surface water streams. It literally bubbles out of the ground and forms the streams, and it maintains cool, stable temperatures all year long, provides nutrients to aquatic organisms. So if our groundwater is threatened, our streams are threatened. If the streams are threatened, the trout and salmon in the streams are threatened. If the fish are threatened, then the $4 billion annual fishing industry in Michigan is threatened. I'll discuss the stormwater runoff in a later question, but the second concept of thinking of water as infrastructure is a lot simpler. It's truly important in my mind as a way to elevate the importance of the freshwater resources that we're endowed with. Pretty much everything we want to transpire economically requires us to be able to supply and have available an abundance of fresh water. The agriculture we depend on needs water for irrigation. High-tech industries and large-scale manufacturing needs fresh water. The tourism industry, the second largest industry in Michigan, is heavily reliant on fresh water from the outdoor destinations and natural environment and ecosystems that make them a destination, to the facilities like Little Caesars Arena, to the restaurants and hotels or hospitals, schools, offices, and homes. All need fresh water, and if we can't get it in the places we need it, then those things won't exist. So talking about water as infrastructure is a strategy, and it's advice that I actually got from a friend who served as a congressional liaison with the Geological Society of America, seeking to influence policy with our elected officials in Washington, D.C. infrastructure is something everyone supports. So if we consider fresh water as part of our critical infrastructure, we should prioritize and manage it appropriately. And third, the area of emphasis of extension of water and sewer utilities. We've seen a growth imperative that grew out of the post-World War II baby boom that caused us a lot of economic pain after these low-density suburbs spread and grew across the state. And not all growth is good. And it's particularly important for every community and township is considering using public funds to facilitate development of roads and subdivisions and rural and semi-rural commercial development to understand how the maintenance of those facilities is going to be paid for. Better, not bigger is a saying that I like to use. We might, it might be a better imperative for our future than thinking about growth, because directing growth to existing communities and promoting infill development over greenfield development is much preferred, and it'll save us money down the road, and we're never going to be able to reverse some of the development impacts on land and waterways as well. And finally, the climate change and growing seasons are getting longer, and our farmland is going to be more valuable than ever. And you know, we also have extra capacity in some areas with roads, and you know, in some areas we have thought about and plan to abandon some of those things until there's a tax base that can support the reconstruction of those facilities. So those are my thoughts on that.
Great, thanks, David. You and Brian gave us a lot to think about on that first question. We're going to go ahead and move on to the second question now. So, Marcy, do you want to take this one first in thinking about highlighting some of Michigan's water industries?
Sure, that'd be great. I mentioned in our area, agriculture is a large part of our economy in Southwest Michigan, and especially specialty crops that I mentioned. And along with that, the agritourism that's built around those specialty crops is really big for our area in terms of bringing people into the area and enjoying those agricultural products that are being produced locally. We also, along with that, have the breweries and wineries and things like that that are, you know, often water dependent also, that are bringing people to our area to enjoy those resources. The other thing I want to mention in agriculture that a lot of people may not know is one of our counties and several counties to the east of us are becoming very big in the seed corn industry, actually. And most of the time you think of that out more in Midwest states, and Michigan is now, I think, #1 for seed corn, and that requires a lot of irrigation to grow those crops. And so that's something that's growing significantly in our area, uses a lot of water, which we have, but of course there's also issues of overuse of water and trying to make sure that there's a balance between that use for agriculture and also making sure that our streams and the base flow isn't affected from that irrigation and use of water. So we gotta make sure we balance those different interests in our water resources. The other thing in our area, of course, I mentioned is tourism is huge. Second home industry is something that is very vital to our economy here in Southwest Michigan, and also the recreational resources that support that, our beaches. We again have to be very careful about protecting our water. Several years ago, we had many beach closures in our area, and it affected tourism. People would go to other parts of the state and skip over our part of the state because our beaches would be closed because of pollution. So again, for that industry to be successful here, we've got to make sure we protect those water resources and make sure our beaches stay open. The other big thing that's really growing in Michigan is water trails for canoes and kayaks. Excuse me. the state just started a new program for designating water trails as state designated trails. So a lot of groups around the state are working to get their water trails designated and on the state DNR's website for promotion, because the canoe and kayak industry is booming. I can't usually drive around without seeing several kayaks or canoes on top of people's cars. So it's growing greatly, and we have the rivers and lakes in our area to support that type of use. So that's exciting. And I'm glad that Brad in his presentation talked about home values as I don't know about industry, but I guess around here, our second home is kind of an industry. In fact, we had a village that in the middle of their town is a lake. And of course, all the highest home values in that village are the ones around the lake. But it was starting to get polluted, and it was interesting. The town is surrounded by a lot of agricultural use, which was sending a lot of sediment and nutrients into the lake. And so the village made a policy decision to use their tax money that they collect, their general fund money, to work through the conservation district and work with the farmers out in the township to pay them to do conservation on their property to reduce the amount of sediment and nutrients coming off the property into the river and into their lake and causing water quality issues because it was causing the home values to decrease. So just kind of an innovative way that in a policy decision that's not that you don't see a lot of people taking their money and spending it outside of their community, but for the benefit, it was worth it. So those are some of the things going on in Southwest Michigan.
Thanks, Marcy. David, I imagine there's some similarities to Southwest Michigan, but probably some really different things up in Marquette as far as water-based industries.
Yeah, but I kind of went into, I looked at the shipping industry, which is big here, as I said before. There are about 100 or more than 100 ports on the Great Lakes. Some of the most important commodities travel through those ports and the St. Lawrence Seaway. We get grain from the Plain States, comes through Duluth. Iron ore from Marquette County, limestone from Alpena, the Alpena area, steel products from Ohio and Pennsylvania, hockey sticks from Ontario. And I didn't have a lot of time to look into the data, but I know anecdotally that port communities have major concerns about the water level in the lakes, which have reached record levels in the past few years. And it isn't projected by the U.S. Army Corps of Engineers that those levels are going to subside much in the foreseeable future. I'm not sure if the higher lake levels will be an overall benefit to shipping on the Great Lakes, but it will benefit some ports and probably cause some problems for retrofitting facilities and the like in other ports. But the longer term view should also consider how population growth is going to affect the opportunities for shipping in some of our lake communities. And what I mean by that is that the world population, we don't think of this much because we've seen population loss in Michigan. So some people probably think I'm all crazy talking about this, but Chicago grew by over 2 million people in 2 decades. That kind of thing is not impossible that we'll see that again. The world population grows at a rate of about 80 million people a year. That's about 10 Chicagoland, new Chicagolands every year, if you think about it that way in the term of resources that we need to house, employ, feed people. And the population in the upper Midwest is perhaps going to experience significant growth because maybe more than any other part of the country, because the projections for climate change say that this is going to be one of the better places to be over the next several decades. And there's going to be a lot of places that are not going to be very pleasant places to be.
having port facilities that can transport not just cargo but also people is something we should be thinking about. I know Marquette has wanted to get back to that. We have very limited facilities here at this point in time. At one time, there were facilities that accommodated all kinds of commodities and transit of people, and that has ceased. We need a customs office here in Marquette to accommodate the people coming in, especially, Great Lakes tourism right now is a thing that a lot of Europeans have partaken in, but and maybe Canadians, so we need a customs office. But there are several UP and northern Michigan cities that have constrained highway access, have limited rail service. And if you look at the Great Lakes freighters, they can move the same cargo as about 700 rail cars or 2,800 trucks on one ship. So at some point, the population here is going to be larger, maybe quite a bit larger. And the transit of those commodities by ship might make a lot more economic sense than it does now, particularly if the shipping season also grows by the ability of the Soo locks to remain open longer due to longer periods of ice-free conditions on the lakes. And I'll come back to that issue a little more later, but that's a topic that port communities should, in my opinion, put some planning energy into now, even if it seems far off, because 40 years goes by quickly.
Great, thanks. Appreciate that perspective. So now we're going to move on to our next question, which is, what's an example of an economic prospect for Michigan water-based industries? And so looking at Genesee County, I'm wondering if there are examples of water-based industries where there's the potential for economic expansion there, Brian.
Yeah, there has been some discussion about that. There is a couple of super secret projects, and then there's also there was a chip manufacturer project near Durand that was at one time talked about that was pretty water intensive. But I mean, if I had to pick a single economic prospect for all of Michigan, I certainly would select agriculture. People always need food. They always need clean water. It's simply our basic needs. And I think Michigan has an abundance of both of those things. I think the Great Lakes also provide ideal soil and climate conditions to grow a variety of crops. Great Lakes, as well as groundwater sources, provide abundant and reliable supply of clean water for agriculture, like spray irrigation that Marcy talked about, that supports both farms and orchards. Farms that grow seed corn, say, and orchards that grow many crops like apples, cherries, and the such, as well as processing facilities that turn those crops into food products. So Michigan crop production and food manufacturing also provides food to local, regional, and even international markets. Again, just to give you a couple of fun facts, because I love these things. In 2017, over 5 million pounds of whitefish were harvested from the Great Lakes. Some of this was sold fresh, some was frozen, canned, breaded, packaged for stores or to be sold at farmers markets, grocery stores, restaurants. Michigan orchard farmers produced over 200 million pounds of cherries. Up near the Traverse City area is a big cherry area. 15 million pounds of wine grapes, which seems to be a little bit more, somewhat, there's some of that in the southern region over near Paw Paw. And they also produced over 1.2 billion pounds of apples. So a lot of agriculture. The apple industry is strong in Michigan. We grow about 20 varieties here. If I had to pick one industry out of agriculture, I would pick apples. You got cool nights and hardy soils make for a great variety of apples. It makes for a great taste in apples. Red Delicious, McIntosh, Ida Red, Honeycrisp, Cortland, Brayburn, Empire, Fuji, Gala, Ginger Gold. I can go on. I just named a few, but apples are the largest fruit crop in the state. And if you look at how water-based the apple industry is in Michigan, there's about 950 family farms that produce on the average about 25.5 million bushels of apples a year. Well, there's approximately 126 medium-sized apple in one bushel. And on the average, one medium-sized apple takes about 33 gallons of water to produce. So 25.5 million bushels of apples requires about 825 million gallons of water to produce. It's a successful water-based industry. And if you want to take it a step further, this amazed me. If you want to produce 1 7-ounce glass of apple juice, it requires about 61 gallons of water. And I would use the pun, food for thought, huh?
That's pretty incredible. David, do you have an example you want to quickly share with us?
So I'd like to frame this question of economic prospects for Michigan's water-based industries in terms of how these prospects relate to climate change, which is currently impacting the prospects for several outdoor industries. According to the Great Lakes Integrated Science Assessments Program, GLESA, which I've provided some links to for anybody interested, the water temperature average, or the winter temperature average for Marquette County has increased by about 2 degrees in the 30-year period between 1981 and 2010 over the previous 30 years. We're experiencing those changes here, but also a lot of variation from year to year. So it's not just a linear thing, but a lot more variation than there was in the cold decades of the 60s and 70s, the latter, which I remember as a kid growing up in Ishpeming up here. But GLESA has created projection maps for temperature and precipitation, the change in the frost-free season length, days below freezing, days over 90, etc., based on greenhouse gas emission scenarios, various scenarios, and it's a tremendous resource. But skiing and other winter sports and tourism are probably going to be the most affected. Here in Marquette, the alpine downhill skiing facilities had some rough seasons recently, not being able to get started as early as they would have in the past, having a harder time maintaining good snow due to the unusually warm days in the shoulder months, and even sometimes what you'd think was the middle of winter. The stores and hotels, restaurants, and bars that support the winter sports are likely to be negatively impacted by that as well. So, and particularly small towns and rural areas that don't have a lot of industrial diversity. Tourism is the #2 industry in the state behind manufacturing. And in northern Michigan, it might be the #1 industry. Just fishing alone. I looked up, I'll match Brian with some figures, but sport fishing in Michigan alone, according to the Sport Fishing Association, American Sport Fishing Association, in a 2016 study, showed that it provides over about $2.5 million in retail sales in the state. And that has a ripple effect of $4.27 billion that's spent in Michigan. There's $1 billion and almost $1.5 billion in wages related to fishing in 38,000 plus jobs. And that represents $287 million in state and local tax revenues. There were almost 125 million visitors that traveled through the state in 2018. They spent almost $26 billion. So there's a lot of potential positive and negative impacts from tourism, but for better or worse, the water-based tourism is one industry that's grown out of the COVID summer of 2020. And that's something that I think entrepreneurs and your convention visitors bureaus will be able to build on. So the economic prospects for paddling, fishing, boat tours, beach and lake vacations, that kind of thing, should be on the upswing as long as the overall economy remains fairly stable or becomes fairly stable. And the length of the seasons for this, for boating, paddling, biking, and hiking are expanding. So more and more years like this one, we have this unbelievable, beautiful day here, where the onset of unbroken winter weather is delayed. That's going to probably become more common according to the trends. And in the north central UP, it's become more and more common not to have snow that builds up until late December and even January. So one of the GLESA projections in the increase for frost-free seasons for the years 2070 to 2099, we could have 40 to 60 more additional frost-free days a year in Michigan. It's a long way off, but we're talking about planning for things. So that trend will be good for the next couple decades for sure, for our non-winter outdoor industries and agriculture, but it could be really bad for winter sports that are not indoor hockey.
Yeah, those winter sports, we definitely need to be looking to those, especially if we're transitioning climate-wise. So this next question is for Marcy, and we're quickly running out of time, so I'm going to ask folks to kind of keep the answers short. But Marcy, in your opinion, what are the water infrastructure needs in your communities?
Oh yeah, I serve a whole region, 3 different counties. So it really kind of depends on if we're in a urban or suburban or rural issue or area. But I would say one thing that kind of is affecting all those different types of communities is aging infrastructure. And it was talked about in the presentations today about planning for maintaining our infrastructure is something that I don't think a lot of our municipalities have done a very good job on, unfortunately. We have our water and sewer systems in our more urban areas that are municipally owned and need a lot of repairs, and it's very costly, as you saw some of the numbers that were put up in the presentations earlier. So I know a lot of our communities are struggling with how to pay for these repairs that are needed to be done on these systems that are aging. And then, of course, in the rural areas, most of those homes are on septic systems. We have over 1.3 million septic systems in Michigan, and a very conservative estimate is that 10% of them are failing. And it's a really big expense if you have to replace a septic system, and especially if it's somebody on a fixed income. You know, to replace a septic system can cost sometimes $15,000, depending on your soils and what kind of system you need. So that's a very large expense, you can imagine, especially if somebody's on a fixed income. So aging infrastructure is definitely an issue for all of our communities in Michigan, I think, not even in the nation, not just Michigan. And I just want to mention real quick, there is a statewide initiative going on right now for the Michigan Infrastructure Council, where they're asking communities to complete what's called an Asset Management Readiness Assessment. And so if you can Google Michigan Infrastructure Council or the MIC, you get to their page, that's all the information about this assessment is right there. And the state's really trying to get a better handle on the needs. And once the state has that information, hopefully there can be some assistance to some of these communities to make these repairs that are needed on these systems. So I encourage people to look into that and participate in that effort.
Great, we'll send information out about that afterwards. So our next question is, can you provide a snapshot of the size of capital assets devoted to water use and reuse in your community and how it is paid for? So David, you're first.
Okay, so the city of Marquette has roughly a $70 million budget for everything. It spends between 10 and 20% of that budget every year on water, wastewater, and stormwater facilities and management. So those expenditures include all the facilities, equipment, upgrades, replacement, construction, distribution, and the expenses to employ the professional and technical staff, rent, debt service, everything. There are two major sources of the funding: capital outlay via financing through bonds, and the other is enterprise funds. And the enterprise funds are what residents, businesses, and the other system users pay for. So the city has three funds, one each for water, sewer / wastewater, and one for stormwater. So the water and sewer fee funds are both based on the amount of fresh water that is used by the taxpayer. The stormwater fee is a flat fee for residential properties, and for other properties, the fee is based on the amount of impervious surfaces that are on the property. So when our engineers get study site plans for new construction, they do calculations for the stormwater discharge from the proposed construction, look at the proposed facilities to manage those, and they calculate the runoff and work with the project consultants for the facility needs that are required to meet the codes. And one of the principles we have in our design guidelines is to not add any storm runoff from the property. Development cannot add runoff. So, but they also provide the details about those impervious surfaces once the final construction is all penciled out to the assessing department of the city, and that is added to the tax bill for the property. Another interesting thing is, really quickly, is our annual street reconstruction projects. The majority of the funding comes from the water and sewer enterprise funds. Those are what the taxpayers pay, because the utilities under the streets are almost always upgraded with those street reconstruction projects. And that also pays for sidewalk repair and extension, because we build sidewalks when we build roads almost all the time, and we repair sidewalks. And so those are paid for from the same funds, as well as the administration of all the water department activities.
Thanks, David. Brian, how about in Genesee County?
Yeah, from a regional perspective, that's really a great question. I can speak about the size of assets of Genesee County. We currently have $440 million worth of assets. This is after depreciation, so really it costs more to build all that. We just supply it with equipment. We just have depreciated some of it over the years. Almost $500 million worth of assets. So this includes 3 wastewater treatment plants, as well as an enormous sewer collection system, associated pump stations, sewer pipes buried in the ground. It also includes a drinking water facility. This is not the city of Flint, just to let everybody know. The Lake Huron freshwater intake, several large pumping stations, as well as a network of piping that make up the drinking water distribution system. Breaking it down a little further, the 3 regional wastewater plants, which are now called resource recovery facilities, and I'll mention why. But in our northern facility, we take in 37 different communities and flows from 4 other counties. In our southern facility, we take in 7 communities and 1 other county. And the facility in the southwestern part of the county takes in 2 communities. These 3 plants combined clean up and recycle over 35 million gallons of wastewater every single day. We recycle the treated clean water back into our local rivers, both the Shiawassee and Flint rivers. And the best part about it is we put it back most of the time cleaner than the river itself. We also recycle our sludge at the treatment plant. Steve Safferman talked about this earlier. We use a process called anaerobic digestion. We stabilize the solids. We take unstable organic sludge solids and we cook it steady temperature. And then we recycle 2 byproducts that are generated from that. One is biogas that we use to operate a generator, also biogas that we use to heat several of the buildings, as well as heat the digester itself, so the process can continue. This helps us save quite a bit of money, both in electricity and natural gas. The second recyclable product generated is stabilized biosolids. We store that as a liquid on site, and the farmers apply it to agricultural land at rates which are beneficial to the crops and the soils. And This offsets the need for the farmer to add synthetic fertilizers, which really helps keep our croplands fertile. Essentially, this is why we're called water resource recovery facilities. We take a bunch of dirty water, we clean it up, put it back in the river, but we also take various waste products and we make them into other usable products at the treatment plant. We recover the resources and we safely return them to the environment. All 3 regional water resource recovery facilities have capital assets in excess of $218 million. And we have operating expenses of about $31 million a year. On the drinking water side, we maintain 1 regional drinking water facility. It actually pumps about or treats about 12 million gallons of fresh water every day from the Lake Huron intake, which is 63 miles east of us. And then we safely provide it under pressure to the faucets of about 17 communities. The regional drinking water facility has capital assets worth slightly more than $192 million with operating expenses of over $36 million per year. So you can see the snapshot of the kind and size of infrastructure that's in place, both water and wastewater, is just amazing to me. We're one of the businesses that cannot, once we hook somebody up or supply them with water, we're extending a promise to them forever. It's not like Sprint or AT&T where you can say, hey, I'm dissatisfied with the service and just switch. We're hooked to them forever. And I believe then we have an even higher responsibility to the public, an obligation that has an even higher level of service that needs to be provided. How do we pay for it all? Similar to Dave, we pay for it in our enterprise fund. But that enterprise fund takes all of those capital expenditures that we've planned out each year, and it also takes the operating costs that we plan every year, the maintenance costs that we plan every year, and the debt reduction that we have. And all of those things combined together are supported by a rate structure that we have, that we charge our, no taxpayer money went into any of this at all. It's all supported through rates alone. Thank you.
Thank you, David. I appreciate your input. It looks like we're out of time and we won't be able to get to any additional questions. Just remind people that if we didn't get to your question today, we will address them in our follow-up email next week. I don't think we've had any new questions come in, but there may be 1 or 2 that we didn't answer from previous ones. I would like to say another round of thank yous to David, Brian, Marcy, Steve, and Brad for sharing their thoughts with us today. This has been a great webinar, so thank you to all of you. I also, before we go today, I wanted to recognize the financial funding that we've received from the Herb Family Foundation and the Pure Oakland Water. I also want to thank the entire Michigan Water School team who have worked over the last 6 years to develop this program. We're only able to hear from a few of them during the webinar series, but many people have contributed behind the scenes. And finally, a thank you for the technical expertise from those on the Michigan Water School Statewide Advisory Council. These webinars wouldn't be possible without the contributions from every single one of these folks. So thank you for taking time to join us today. We hope you've had we hope you have a great evening.